Hey there, everyone. Welcome back to our channel. I hope you're having a fantastic day. If you're new here, don't forget to hit that subscribe button and ring the bell so you don't miss any of our future videos. Today, we're diving into a crucial concept in machine learning, cross-validation. It's a technique that can really enhance your models and help you avoid some common pitfalls. So, whether you're a beginner or you've been in the game for a while, stick around. You're going to learn something valuable. Now, let's kick things off with a question. Have you ever wondered how data scientists ensure that their models are reliable and perform well on new, unseen data? That's where cross-validation comes in. It's a powerful method used to assess how the results of a statistical analysis will generalize to an independent dataset. In simpler terms, it helps us figure out how well our model will perform in the real world. So, let's break it down step by step. Cross-validation is essentially a technique for assessing how the results of a statistical analysis will generalize to an independent dataset. The most common form is k-fold cross-validation. So, what does that mean? Let's say you have a dataset of 1,000 samples. In k-fold cross-validation, you would split this dataset into k smaller sets, or folds. Typically, k can be any number like 5 or 10. For example, if we choose k equals 5, we would divide our dataset into 5 equal parts. During the training process, we take 4 of these parts to train our model and use the remaining part to test it. We then repeat this process 5 times, each time using a different fold as the test set. At the end of this process, we average the performance metrics to get a better estimate of how well our model is likely to perform on unseen data. Let's look at a practical example. Imagine you're building a model to predict housing prices based on various features such as size, location, and number of bedrooms. You have a dataset with 1,000 houses. If you just train your model on the entire dataset and then test it on the same data, it might perform well. But that's misleading because it could just be memorizing the data it saw instead of learning patterns. By applying 5-fold cross-validation, you can ensure that your model is robust. The first time, you might train on houses 1 to 800 and test on 801 to 1000. The second time, you might train on 1 to 700 and 801 to 1000, testing on houses 701 to 800. When you average out the performance over all 5 folds, you get a more accurate representation of your model's predictive power. So, why is cross-validation so important? Here are a few key benefits. 1. Reduces overfitting. It helps to ensure that your model isn't just memorizing the training data but is learning to generalize from it. 2. Better use of data. Instead of just a single train test split, you're using all your data multiple times, which enhances the model's learning. 3. More reliable estimates. By averaging the results from multiple folds, you get a more reliable estimate of model performance, making it easier to compare different models. However, it's important to note that cross-validation isn't perfect. It can be computationally expensive, especially for large datasets, and sometimes the results can still be biased if the data is not randomized properly. For example, if your data has a time component, like stock prices, using random splits might not be ideal, as it can lead to future data leaking into the training set. There are also variants of cross-validation, like stratified k-fold cross-validation, which ensures that each fold has the same proportion of classes as the original dataset. This is particularly useful in classification problems where you have an imbalanced dataset. To sum it up, cross-validation is an essential part of the machine learning process. It allows you to build models that are not only accurate but also reliable when faced with new data. Whether you're working on a simple regression model or a complex neural network, incorporating cross-validation can really elevate your work.
If you found this video helpful, please give it a thumbs up and share it with your friends who are interested in machine learning. And I'd love to hear your thoughts. Have you used cross-validation in your projects? What was your experience? Drop a comment below. Don't forget to subscribe for more educational content, and we'll see you in the next video. Happy learning!